People, this is chapter 10. In your textbooks, it's about sampling. Yesterday, we've also talked a bit about sampling. Just to refresh your mind about a few concepts, we've talked about a population. And we said that a population is too big to include everybody in your survey. You cannot include all residents living in Gauteng, for example. It's impossible because you don't have time and you don't have money to do that. Okay, you don't have the resources. And therefore, we need to sample. So a sample is a subset of the population that you are targeting. Okay, and the population, we said, consists of sampling units or units of analysis, and the units of the analysis is, for example, the individuals or the businesses that will take part in your survey. So from a population, we need to do sampling, where we select a smaller group of people or respondents to take part in the survey. So the outcomes of this chapter, we need to understand two major classes of sampling. We're going to look at probability and non-probability sampling. That's the two main methods of sampling. We're going to look at the details of the methods of sampling. So we have probability sampling and different methods underneath them. We have non-probability sampling and different methods underneath them. We're going to look at those methods. We have to explain the sampling methods, and you also have to understand what would make sampling potentially hazardous if you try to draw important conclusions about the population. Things like unrepresentative samples, for example, makes it a problem if you want to draw important conclusions about a whole population. If your sample is not representative, you cannot draw important conclusions with regards to your population. And then we need to look at what are some of the principles when we do our sample size, when we decide on the sample size. So just before we now start with all the theory, when you come to your proposal, you will see there is a section in your methodology dealing specifically with sampling. There you need to indicate to me which sampling method did you use and what is your sampling size and why did you decide on that method and why did you decide on that size. Okay, that is what I want to see in your proposal under methodology, research methodology. So it is impossible to include we've already said that, the entire population in your study because we have restrictions like time and cost. Therefore, you need to make use of sampling. It's important to draw a sample in such a way that it would be valid to generalize its result to the population. So in other words, we need to draw representative samples, samples that are an accurate description of the respondents that we find in the population. If the sample is too small, then we cannot generalize, for example, to the whole population. And we will look now probability sampling. Those are the methods that make your sample more representative. Non-probability sampling is not representative of a population, but it does have its time and its place when we can use it. So we need to look at today, how do we draw then scientific samples? There needs to be a way for us as researchers to make sure that we draw samples in a systematic and scientific way, and we need to explain how we sampled. So as I've said, there's two major classifications of sampling. Probability sampling. If you hear the word probability, you can immediately think of representative. It's representative of the population, or it contributes to the representativeness of your population. Whereas non-probability sampling methods are not necessarily representative of a population. Some characteristics of probability sampling method: each element in the population has the same probability to be selected as a respondent. So if I decide to do a survey on students at VUT, every student at VUT, when it comes to probability sampling, has a chance of being selected to be part of the sample. It's not to say that you are going to be selected, but you have the same chance as any other student. That is that non-zero. Everybody has the same probability of being selected. So everybody has an equal chance of being part of the sample, and that is a characteristic of probability sampling. Selection of elements is random, and it's objective as well. There's no bias. You get a sample frame or a sample list. Remember, we talked about sampling frame yesterday. I can get a list of all the students at VUT, and I can objectively, by assigning numbers to those students in a systematic way or in a stratified sampling, or we get to those things, but I can select students in a systematic way from that specific list. So there's no human or subjective interference. I won't know who the students are because they are numbered on that list, for example. 4 methods that's included in probability sampling: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. So these 4 methods are probability sampling methods. So you're going to write to me in your proposal, for example, the research will make use of a probability sampling method, namely simple random sampling. And you have to explain what is probability sampling and what is simple random sampling then. And you have to tell me, I've chosen this because A, B, and C. All right, so you need to provide motivation and support for your decisions. Now, let's look at the different probability sampling methods. We have simple random sampling. We need a sample frame, an up-to-date list or sample frame of all possible, of the population basically, all the units of analysis. So if I want to do that in VUT or on students, VUT students, I need a list of all those students. So that is up to date. Currently, who is all the students that are registered at VUT if I want to do a study on them. Each population element has to be numbered sequentially to be uniquely identified. So you need to assign. What do we have at VUT? We already have student numbers, so we can use that as part of our sampling frame. Drawing of the sample involves the generation of a predetermined number. So before you can go on, you first need to determine how many respondents do I need. So let's say, for example, I don't know how many students are at VUT. Let's say 20,000 students. How many students do I need from the 20,000 to make my sample representative? Do I need, for example, 10%? Then I need 2,000 students to participate in my study. So before you can go on with simple random sampling, you first need to determine how many respondents do I need. Okay. So there's different formulas to work out that. At the BTech level, I'm not going to expect you to draw precise representative samples, but you need to understand the theory for future reference, and you need to be able to explain the theory. But there are formulas on which we calculate. We look at sources, literature sources, what has similar studies also done, how was their samples drawn, the sample size is determined, and then from that we can make up our sample size before we start with the random sampling. Members are determined in a random way. One can use a table of random numbers. If you look in your textbook in chapter 10, there is a table which we can, it's a table including IQs of different learners and numbers of those different learners. And from that table of random numbers, one can pick respondents until you get to the size, the number of respondents that you need, or you can use computer software. Now, to make simple random sampling easy for you to understand, I can also use the following example. If we take our class, for example, we are supposed to be 75 students in this class. I can put all the names or all the student numbers of the 75 students in this class in a hat, but I only want to have 10, my sample size out of the 75. I only need 10 respondents. So I'm not using all 75, I need 10, I determined that. So I take the hat with 75 names and I pick out 10 names out of the hat. I randomly selected them out of the hat. And that is simple random sampling. everybody of the 75 students who were in the hat, they had an equal chance. We cannot say, and I did not interfere with the process and I couldn't see the names or anything. It was objective. I picked out of the hat. And that is simple random sampling. And that is the easiest way of sampling if it comes to probability sampling. But we can also use a table, like it says there, table of random numbers, where you have a table of all the students and each student is assigned a number, or each of the respondents is assigned a number, and then you go in a systematic way. If you need 10 respondents, in a systematic way you get it from the table. All right, that is simple random. Do you understand that? Then we get systematic sampling. This must also happen in a systematic. You must also always be able, when you do your sampling, be able to explain how did you come to your sample size and why did you use the sampling technique and how did you implement that technique in your specific study. You need to be able to explain that. How did you apply it in your study? Okay. And all of these methods, these probability and even the non-probability, they are based on scientific explanation. You need to scientifically explain. All right, and systematically. You need to work according to steps, processes to make it clear and to make it valid. Your results must be valid. So systematic sampling is drawn by systematically moving through the sample frame. Remember the frame, if you hear the list sampling frame, you think of a list of respondents. Everybody that's on that list of respondents. If it's businesses, individuals, you think of a list. And selecting every second, every third, every fourth person or business on that specific list, or element referring, it can be an individual, it can be a business, or whatever you are focusing on. Households can also be an element. Each element will be randomly chosen from the list using a sampling interval. The sampling interval, every second one, every third one, or every fourth one, depending on how you want to do it. But the interval refers to how far is the one value from the next value. Every second one on the list, every 10th one on the list. Also, you need to determine how many do you need. Okay, the size. So the sampling interval there is just saying the distance between one element and the next for the sample. So you can also use systematic sampling. There you cannot pick the numbers from the hat, you need the list, the frame, because it's not, you need to pick every second or third one in systematic sampling. Stratified sampling. Stratified sampling is a bit more complex. Here you need to split your population. Remember, the population is everybody that meets the characteristics to be part of your study. You can group them into subunits, or we can call them strata. Strata are groups of elements that share the same characteristics within the same population. Strata will be decided based on characteristics, including in the population parameters. Samples are then drawn from each stratum using random sampling or systematic sampling. I'm going to give you an example now. And it's used to ensure high representativeness of the sample, and especially where the population is diverse with different characteristics. Stratified sample, for example, if we have a nightclub, and in that nightclub there's both males and females going to that nightclub, okay? But females are a bit more going to the nightclub. 60% going to the nightclub are females. Males are 40% going to the nightclub. So we've identified two strata there. We've identified males and females. Stratified sampling, we divide into strata. We have males and females. But males and females might differ in how they experience the nightclub, in why they go there. They might differ in terms of that. We want our sample to be representative. So what do? We need more females in our final sample than males, because they are more there. There are more females there. So in our final sample, we do need more females than males, because in general, the population consists of more females than males. Are you with me? Okay, so we've identified then strata, male and female. In our final sample, we want more females because the population has more females and lesser males. Now, within those two strata, we will do random selection. We do not want the entire 60% of females to complete our questionnaire or whatever. We are going to randomly select from them. So we put all the names of the females in a hat and we draw more females. 60% of our sample must be female. We draw from the hat. The 40% must be male. We draw from another hat because it's a different strata. That is the random sampling. So first you have to identify your strata, the characteristic that differs in your population that you want to be also represented by your sample. And then from there on, your second step will then to be draw randomly from each strata or subunit. What do they call it? Subunit. Do you understand that? Sort of. Yeah, it is difficult. You need to know that populations differ and that sometimes we want to increase representative of our sample and therefore we take that different characteristics into account so that our final sample represent also the entire population. So why do we use this type of method? To increase representativeness, and we use it because the population differs. There's huge differences or there's differences, significant differences in our population. So as I've said, in a nightclub, males will go to a nightclub maybe for different reasons than females might go to the nightclub, and we want to proportionally identify why they go there. But there's more females than males, so we need in our final sample more females than males because that is the population. The population consists of more females than males. Okay, think about that. Cluster sampling, it's also similar to stratified sampling. This is also where the population is divided into subgroups or usually smaller than strata. They are called clusters. And this also involves random selection of clusters from which either all elements or a randomly selected number from the sample. Clusters that are formed should be as similar or heterogeneous as the population, and this is also used then to increase representatives. So here you again have to identify strata, but smaller groups you identified with similar characteristics, clusters we call them, and within those clusters, that small groups, you do the random sampling, again to increase the representative. So it's very similar to the previous one, but here we have even smaller subgroups than strata. We have clusters that are used here. Within each cluster, we can draw random samples. Okay. I just want to see, I do have an example here. So we can divide in this type of sampling, we can look at restaurants, for example, in different provinces. If we maybe want to determine how satisfied waiters are with their wages in restaurants in different provinces across the country, we will need to follow some kind of cluster sampling by firstly provinces, then dividing that into, for each province you will need a cluster of restaurants, and then in that restaurant you will randomly select the waiters that will participate in the study. So it's a breakdown so that you can increase representativeness of your sample at the end. So those are all probability sampling. So simple random sampling, systematic sampling, stratified sampling, and cluster sampling, they all fall under probability sampling. For probability sampling, you need to keep in mind that it's more representative of a larger population. You can generalize the results more easily. And you need sample frames if you look at probability sampling. Then you will need sampling frames or lists of respondents. Let's go to the non-probability sampling methods. These methods do not make use of random selection of population elements. So the picking out of the hat does not happen here. The every second one, it does not happen here. Okay? Because you do not have a list. You do not have a sample frame in this case. So you cannot do random selection if you don't have that list. All right. So non-probability sampling does not make use of random selection of population elements. It's dangerous in this case to draw important conclusions about the population. Why? Because non-probability sampling is not necessarily representative of the population. Why? Because you did not make use of randomization. That is why it's not representative. All right. You don't have a list to do the representative sampling. So it's not representative. So you cannot make a conclusion if you've done 10 respondents and you find that all 10 respondents that you've done based on your own sampling in non-probability, you find that all 10 of them are not interested in studying towards a further qualification. You cannot say, no grade 12 is interested in studying further towards a qualification. That's dangerous to make if you did not use a probability sampling method. So the advice is to limit the use of non-probability sampling and to rather look if you can use a probability method, but it is not always possible to use probability sampling. Some of the advantages or situations in which we can use non-probability sampling is when we do not have enough time to go through that whole process, calculating how many people and the sampling intervals, calculating those ones and dividing into clusters. That can be time consuming. If we don't have time for that, in other words, an answer is needed soon to a specific question, an issue that a company is struggling with or that society is struggling with, then time is limited, then one might look at non-probability. When you want to test a measuring instrument, you've developed a new measuring instrument, you need to test whether that instrument is actually understandable, you want to make it see its reliability and its validity, then you can make use of non-probability sampling because you are in a testing phase of a measuring instrument. Then you can use this. And also when you do your testing of your instrument, all new instruments need to go for a test, a pilot test, a questionnaire. It goes for a pilot test so that we can determine if respondents understand your questionnaire, if the questionnaire can statistically be analyzed, and if the questionnaire is reliable and valid. So we need to do pilot studies for our questionnaires. So, but if we do what I want to say is if we do the pilot study, we still need to explain how did we do that pilot study. What sampling did we use to conduct the pilot study, and that is why it's also in here. All right. So if you're going to design a questionnaire for your master's degree, for example, you'll first have to pilot your questionnaire. Pilot on a smaller number of respondents by maybe making use of a non-probability sampling method. Preliminary studies have to be done in the development stage. As I've said, we are in a developmental phase, testing instruments, then we need to do non-probability sampling maybe. If we don't have sufficient financial resources to do a probability method, then we can move to non-probability, but then we have to explain why did we use non-probability and why it is suitable. And if you don't have access to the population or to a sample frame, then you need to look at non-probability sampling. So in the case as I've used with the festivals, you don't have a list of visitors going to the festival. There's no framework, no sampling frame. Therefore, you will have to move to a non-probability method. So there's also 4 methods under this one: convenience sampling, quota sampling, snowball sampling, and purposive sampling. Convenience sampling means that the population elements are selected based on the fact that they are easily and conveniently available. It's quick and cheap to use. It's useful in exploratory research and also for pilot studies. For example, a convenience sampling method is when you approach the first 100 customers entering a department store and ask them to complete a questionnaire for you. Because you're doing it simply because it's convenient. That's why you're doing it. It's convenient. When we go to a festival where you don't have the sample frame, you will most likely also do convenience sampling. Who is conveniently accessible to you at the festival terrain, for example. So it's about convenience. Who is conveniently accessible to you? So this is mostly used then also for pilot studies. Then we have quota sampling. The researcher has to identify categories of people that need to be in the sample and the required quota or number in these categories. Sampling is then done by means of convenience sampling until the quota have been reached. So again, if your population consists of 55% females and 45 males, you might want to have more females in your sample, your final sample, than males. So then you will conveniently approach, using convenience sampling, females until you have 55%, until you reach the quota of 55. And for males, you will go on conveniently until you reach 45% males. But there's no random selection, no real scientific explanation for why you are doing it this way. But it does have a place and a space to use, as we've said, in testing phases and so on. Snowball sampling can be used. It's used in cases where the population is difficult to find and where the research interest is in an interconnected group of people. So in snowball sampling, let's say, for example, I want to understand let's just take an example, customer satisfaction at Emerald Resort and Casino. But it's difficult for me to access the resort and to distribute questionnaires at the resort. Now I can think of at least 4 people that I know that have visited Emerald Resort and Casino, and I forward a questionnaire to them, to those 4 people. And I ask that 4 people, do you know anyone else that has been to the Emerald Resort and Casino within the past month or so? And then they say yes or no, and they give me some contacts of some other people, and then I also send it to them. And I ask that people, do you know anyone? So you see it snowballs. So you can use that as non-probability. So there we can see the starting point. Make contact with 1 or more people who belong to the population. They are handed a questionnaire and then ask for information about others who have the same characteristics. So that is also a possibility to use. And then purposive sampling is used in situations where the sampling is done with a specific purpose in mind. So you have a specific objective for your study, which is maybe unique, and you also don't have easy access to your population. You might want to target specific responses based on what you are looking at in your study. Maybe it's a field that is not well known, and there's only a few number of experts in that field, and you want to get the experts' opinions. With a purpose, you approach those experts. That is purposive sampling, because you know that they are experts in the field and that they will be able to answer the questions that you are posing. So you go to them with a purpose in mind. That's the only way that you will be able to answer your research question. That is purposive sampling. So the 4 methods there under non-probability, it's convenience sampling, quota sampling, snowball sampling, and purposive sampling. What you also need to consider then with your sampling, we've talked about that as well before, the size. How many respondents do you need? Factors to consider. Type of statistical analysis plan. Now at this stage you are not planning on statistically analyzing your data. If you go to a master's, yes, then you will have to statistically analyze your data. You are going to say, oh, I want to do, for example, a t-test or a factor analysis with my data, but what must my sample size be in order for me to do that factor analysis or that t-test? So those calculations actually also indicates to you a preferred sample size. If I want to do a factor analysis, I need a sample size of at least 100 respondents. So that will determine your sample size. At this stage, as I've said, you are not going to worry too much about sample size because you're not going to do the statistical analysis. You are now in a learning phase and exercising research methodology. Okay. Accuracy of the results, how accurate does your results need to be, and what are the characteristics of the population? How large is the population that you are aiming at? Because that will determine how many respondents you will also need. There's a formula that we use for that to determine the population size and then to look at what sample size is linked to the population size. And the formula says at about 100,000 respondents, the number, I think it's 384, is sufficient. For any number 100,000 and above, you need 384 respondents. That is what my formula says. As that number, the 100,000, decreases, the sample size will also decrease with that. Okay. But for anything above the 100,000, 384 is deemed to be appropriate. That formula has been tested and proved correct. Okay. So characteristics of the population, mainly also how big is your population. So there it says we can use formulas and rules of thumb to determine that sample size so that it will be representative. Sample size is very important as well for representativeness. So you need to know how large is your population so that you can draw a sample size that is representative. And that is the formula that I've just mentioned now. You also need to look at your budget. If you do your sample size and see if your budget will allow you to do that many or that amount of questionnaires and see if the cost is within the budget. Then there's a table in your textbook, table 10.2. It deals with sample size. It just lists, the table lists 8 factors that you need to take into consideration. It says the type of research that you want to do. Page 200. You need to look at, the table also says financial constraints, the importance of the results, the number of variables that you need to study. More variables means that you need a larger sample, for example. Methods of data collection. If your data collection uses inconsistent methods, you will need a larger sample. Accuracy that you need, accuracy of results is greater when the sample size increases. So the more respondents you have, the more accurate your data is or will be. So if you need accurate data, you need to increase your sample size. And then also the size of the population. So those are some of the considerations that you can look at in order to determine sample size. Okay, and I think that is about it for sampling as well. Yes. Okay, any questions about the sampling? So remember, for your proposal, you need to explain to me in a step-by-step way what sampling methods are you going to apply and how are you going to apply that. Okay. Thank you, guys.